Hey, good morning, all you MRWC fans. This is Mr. Ainsworth. We're going to get right into it here with another prep for our first big activity on constructing the square root of 2, or maybe even the square root of 3, and beyond that, maybe square root of 8, maybe square root of 12. Okay, so what we're going to do is we're going to go through the prereqs here, the basic skills for constructing the basic roots. These are irrational numbers, as you guys know. The square root of 2, the square root of 3, square root of 4, and the square root of 5, and we're going to use a compass and a straight edge and go through it step by step. But this time you're not going to see my hands. You're going to see some digital tools. So I'm going to grab what's called the compass here. We've got a digital tool called the compass, and we're going to do the constructions here the way the Greeks did. We're going to use a compass and a straight edge. Now this straight edge here kind of looks like a ruler, okay, but you really only need the straight portion of it, not the marked divisions on it. So we're going to go through how to construct the square root of 2, which you've already been through, but then we're going to extend that, and we're going to use that technique to get the square root of 3, and then, believe it or not, the square root of 4 and the square root of 5. Okay, so we're going to get right to it here. What we're going to do, first of all, is take a look at the square root of 2. So I'm just going to take a look at the decimal value of the square root of 2. And you know what? So you don't believe me, I'm going to just show you here. So I'm going to grab my handy dandy, called the TI-84 here, and just talk about the square root of 2. Now the square root of 2, if you don't believe me here, let's just work it out. The square root of 2 is about 1.414, okay? So I'm just going to make a little note of that here. Okay, so this is approximately equal to 1.414. Okay, so it's obviously between 1 and 2. All right, it's less than 2, greater than 1. All right, so what do we want to do here first is construct 2. So what I'm going to do is take my handy dandy compass here, and we're going to do it the way the Greeks did it. We're going to adjust our compass from 0 to 1. All right, the closest you can. Now, I'm on a computer here, and it's not the easiest thing to do. All right, so go ahead and adjust your compass from 0 to 1. You guys can be a little bit more accurate than me, probably, because this is just, oh, that's pretty close. Okay, so adjust your compass from 0 to 1. All right, and go ahead and rotate here. Let's go ahead and rotate. All right, and notice that the arcs are thin right there, so do that. So go ahead and rotate, and wherever it intersects the number line is 2, right? Because I just adjusted the radius between the pointer and the tip from 0 to 1. So I found this point right here. All right, and that is 2. This point is 1, and this point is 0. Okay, so the distance between the two red dots here on the number line is 1 unit because I adjusted it to 1 unit. Okay, now in order to construct the square root of 2, one of the key concepts for this one right here is to construct an isosceles triangle with side lengths 1. So let me just put the key up here. Okay, we want an isosceles triangle here. Isosceles triangle, legs equal to 1. All right, so basically, if you want to draw this, just so you can see it right here, let me get some room up here. Let's go up here. Okay, it's going to look like this when we're all said and done. Okay, so it's going to be a isosceles triangle, and both legs are equal to 1 unit. And then we're going to prove, okay, that the hypotenuse is length root 2. All right, and I'll show you how to use that fact to get root 2 on the number line, which is going to be somewhere between 1 and 2. And obviously it's going to be less than 1.5 units because this is less than 2, but it's also less than 1.5, which is about halfway between 1 and 2. So that's my goal. I want to construct an isosceles right triangle with the side lengths equal to 1 to get root 2, and then once I get root 2, it's easy. That's my goal. Okay, so what I'm going to do is I got to construct a perpendicular bisector through 1. All right, so that's pretty easy to do. We've done that in the previous constructions. So using the points 0 and 2, I'm going to go a little bit more than halfway, and I'm just going to adjust my radius here, so a little bit more than halfway. Pick a different color here so you can see a little bit better here. And I'm going to construct an arc here. Switch hands, okay, just like that. And then notice I do the same thing here. Oops, I just messed up right there. You're not supposed to change the radius. So let me just double check that. Okay, it's wrong. Okay, so let me go back here. I didn't mean to mess up the compass. Okay, so you have to have it exactly the same way you started. Okay, so notice it's the same radius here. Switch hands, move it over here to 2. Don't mess with the radius now, and go ahead and construct that second arc. And notice that the 2 green arcs intersect. Okay, let me point out the intersection points right here in red. Okay, so it's easy to see. All right, and then what you want to do, all right, is grab your handy dandy straight edge right here. You guys call it a ruler, but it's just a straight edge right here. Line up the 2 red points. We'll call those intersection points. Okay, and let's draw that perpendicular bisector through 1. Let me draw this. Now you want your lines really thin, so what I suggest you do is follow me here. Okay, so make your lines really thin and light, and as well as your arcs. That way you'll be more accurate, because accuracy is really, really important here. Okay, that's not perfect, but it's pretty darn close. Okay, so now I have a right angle. Okay, a right angle right here, and I found this intersection point. So let's give these points some names here. I'm going to call this point A, this point B, and this point down here, let's call it C. Triangle ABC is my triangle that I want to form. Okay, so what I'm going to do is I'm going to grab my handy dandy straight edge again. Alright, so I'm going to bring it over here, and I got to line up A and B and draw my triangle. Okay, so line up A and B. You know, on the computer here is a lot more difficult than on paper, I can guarantee you. Okay, so here we go. We're going to draw the line from A to B. So notice I've done that there. Okay, and let me highlight the triangle just to show you what triangle I'm talking about. Okay, I'm talking about triangle ABC. This is what's called an isosceles right triangle with side lengths equal to 1. So A to C equals 1 and C to B equals 1. Why? Because look at from A to C, it's from 0 to 1. It's 1 unit. Okay, so that's an isosceles right triangle. So let's go ahead and label it right here. So this distance here from, okay, that's 1. Okay, and that's 1. You don't have to draw those. Okay, that's 1, 2 here. So that both legs are equal to 1 right there. And just to show you, and just to review what we did on the previous lesson here, if you use the Pythagorean theorem here, here we go. So 1 squared plus 1 squared is equal to AB squared. I've done this in the previous lesson. Okay, 1 plus 1 is equal to AB squared. And we get 2 equals AB squared. Okay, and because of that, if you square root both sides, you get the square root of 2 is equal to AB. So let's label this root 2. So now we know that that's root 2. Okay, and I used the Pythagorean theorem there to generate that. I know that AB is length root 2. Now because of that, you grab your little tool that the geometers, the Pythagoreans, did back in the day. I'm talking about 2,000 years before Christ, people. Okay, and because of that, this stuff's really old. Okay, and you want to adjust it from A to B. Yeah, I'm limited on these digital tools, so let me do it this way, from A to B this way. Okay, you can adjust it above it or below it. Doesn't really matter, does it? Okay, so adjust it so that it's the distance from A to B. And be very precise, because this is the last and final step of the construction. Okay, and I'm going to switch colors here to, I don't know, blue is good. All right. And so notice it's adjusted from A to B, which is length root 2. That's the key. Now, if you want to find root 2 on the number line, you just swing an arc down. Let me change that. Let me change. I always tell my students to draw the arcs very thin and light. Okay, so let's pick the thin. So wherever this arc meets the number line is root 2. So let's go ahead and denote that. Let's label that. You got to label as you go. So right here is the square root of 2. Right there. Right where I'm pointing, where that red dot is. So wherever the arc intersects the number line is root 2. And remember, this is approximately equal to 1.414, which is obviously less than 1.5 units. And notice that it's less than halfway. That's how you tell if you're accurate or not. I mean, obviously it's less than 1.5 and that's less than 2. Okay, those are the less than symbols. So you got to make sense of your constructions, and whatever you construct, it has to look accurate. So accuracy is important, so remember that. In fact, let's write that out, okay? So accuracy, oh, my computer's going slow again, is important. Oh boy, I hope I can finish this this video. We'll see. Okay, I'll do my best. Okay, so here we go. Now, we're going to take this and we're going to extend it, and we're going to get root 3. All right, so here we go. So let me put my tools down here so I can just keep organized here. Let me bring my compass over here. Like I said, this is not the easiest thing in the world to do. Now to get root 3, okay, you kind of need root 2. So as I said earlier in my previous lessons, excuse me, to get root 5, so let's go ahead, let me just draw a little figure right here. Okay, so to get root 5 on the hypotenuse on a right triangle here, we're going to construct root 2, which we know how to do. We just did it. So the base is going to be root 2, and the hypotenuse is going to be length 1. Wait a minute, why am I saying root 5? I mean root 3, sorry. That's a little mistake right there. I was thinking one thing and I wrote down another thing. So let me fix that right here. Sorry about that, guys. So let me re-explain things right here. So to get root 3, we're going to use root 2 and 1. The reason why is because if you square root 2 and add it to the square of 1, that's going to give you the square of root 3. Okay, why? Because 2 plus 1 is equal to 3. Alright, so if the side lengths are root 2 and 1, and you can look at your previous notes because we've done all this before. Alright, we're going to get a triangle with the hypotenuse length of root 3. So the goal is to repeat what we just did here in the first construction, but then we're going to continue that, and we have to learn how to get a perpendicular here with length 1 at root 2 though. Okay, not at 1 like on the previous construction, but at root 2, and then of course get the triangle and continue and get root 3. If that didn't make any sense, let's do it. Okay, so here we go. The first thing we do is we repeat everything that I just said earlier. So let's do it. Okay, so adjust your compass from 0 to 1. And by the way, this is a video, right? So use it accordingly. I mean, properly here. Since it's a video, you can pause and play as much as you want. Okay, what I suggest you guys do is pause and play all the time. Watch it, pause it, and then perform it. And then play it. Watch it, pause it, perform it. And then you just take yourself all the way through. Okay, so let's get an arc here. Here we go. Let's construct an arc and let's find 2. So I just found 2. I'm talking about 2 on the number line there. So if you adjust your compass to 1 unit, if you go to the right 1 unit, you're obviously at 2. Okay, so you got to label as you go. If you don't label, then you don't really know what you're doing. So you got to label as you go. So I adjusted from 1 to 0 or 0 to 1, and then I rotate, and I found 2. I'm just going to repeat everything that I just did here. So now what I'm going to do is find root 2. So I come over here, and I want to construct the perpendicular bisector between 0 and 2, which will run right through 1, just like I did over here on the left. So I will go open up my compass a little bit. I'm going to use the same color so you can see that it's the same idea. Okay, so here we go. So I'm going to construct 2 arcs of equal radius, 1 arc at 0, switch hands, because, you know, we're ambidextrous here, okay, especially on the computer. And then you grab your handy dandy straight edge here, go ahead and go for it, and bring it over here so we can use it. Line them up. Now, if you don't know what points to line up, let me help you out. Okay, wherever the 2 green arcs intersect, that's where you line them up. And it better be vertical. If not, then you made a mistake. Okay, so you got to construct 2 arcs of equal radius. So once again, you pause and play through the video and just take yourself through it. Okay, so now it looks identical to the first construction right here. Okay, I've got my triangle right here. I've got points A at 0, point B up there at the top, point C right down there at 1. Okay, that's 1. Okay, and we draw our triangle just like we did to get root 2, because I need to know where root 2 is on the number line. Alright, so let's do that. So to do that, we need your handy dandy compass again. Okay, so let's line them up. Let's line up A and B like we did before. Here we go. Okay, now be accurate. I had to readjust here because I have to be accurate. Because if you're not accurate on this step, if you mess up on the root of 2, well, guess what? Everything else is going to be wrong or not accurate, one of the two. Okay, so there's A to B. There's root 2. There's the square root of 2. So let's put the right angle in, and let's highlight my triangle here, just like we did before, just so you can see some continuity or some, similar things going on between the first construction and this one here. So I need to find root 2 on the number line, and then I'm going to build this triangle. As I was saying earlier, we need a triangle that has the base root 2 and the height of 1 to get root 3. So I need to find root 2 on the number line, and that's easy to do. Okay, so here we go. Let's line it up again from A to B. So line up that compass from A to B. Adjust it, just like I did right there. Be accurate here, because if you mess up on root 2, guess what? Everything else is wrong. Okay, so let's get some colors here. Let's use the same colors as before just to make everything consistent. Okay, so construct an arc down here. I just found root 2. Okay, so pull that off to the side, label as you go. So there is the square root of 2, just like before. So I just repeated the same thing. Okay, now I need a perpendicular of height 1. Okay, so what I need to do is I need 2 points that are equidistant from root 2. Now pay very close attention to this. This, for some reason, this is where the mistakes happen for people doing this construction, because there's a lot of things overlapping here. Okay, so everybody place your compass at root 2. Now watch carefully. Again, always watch before you do things here. Okay, now I need 2 points to the right and to the left of root 2. 1 point to the right and 1 point to the left. I would suggest that you move your compass to the right of 2 so the arcs don't overlap too much. Now I'm going to switch colors just so you can see. And I need a point to the right of root 2 and another point to the left of root 2 over here somewhere to the left. And you can swing an arc above it, but then all the arcs are going to overlap. So I'm going to swing an arc below the line here. And it's going to be in purple, just so you can see things a little bit more clearly here. So I suggest you do it above or below the line as opposed to above the line. So I'm talking about these intersection points here. I'm talking about point X here and a point Y. If you have to rewind the video and watch that step, I said you got to find 2 points that are equidistant from root 2. One on the right at Y, one on the left at X. Okay, so that's super important right there. Now using X and Y, I'm going to construct the perpendicular bisector right through root 2 because I need another perpendicular. So again, if you have to watch the video again, rewind it as many times as it takes. Sometimes it takes 3 or 4 times until you figure out what's going on. Now I'm going to line up the compass at X here. Now I'm going to open up the compass quite a bit. I'm going to construct a couple arcs up here at the top. Now all you need is a perpendicular bisector from between X and Y, and I'll run right through root 2. And I can draw the full arcs, or I can just intersect a few arcs above the number line up here, which you've seen me do before. So let me pick, I'm going to pick green right here. So what I'm going to do is I'm going to construct one arc here, Okay, I'm going to switch hands. Okay, I'm going to move it over here to the other point at Y. I've got to move it up. And notice these arcs intersect above, directly above root 2. Directly above root 2. Why? Because I'm trying to construct the perpendicular bisector. I didn't show the complete arcs above and below the line because I didn't need to. Because all I need to do right now is get my handy dandy straight edge right now and line them up. Okay? You're probably asking, line what up, right? Well, okay, line root 2 up with this point right here. Let's give it a name just so that we can talk about it here. Let's call this point, I don't know, W. Okay, so line up root 2 and W. So pause the video right there if you want, but that's the perpendicular or perpendicular bisector right through X and Y. So I'm going to construct that. Here we go. Notice went right through root 2. By the way, we're almost done, okay? Okay, so I've got a perpendicular here. Now I've got to get the vertical segment length 1. I've got from A to root 2 is obviously length root 2. I need a vertical segment of length 1, and that's easy to get. It's just from B to C. So I'm going to bring my compass over here. I'm going to adjust it from B to C. Again, pause the video if you want to. Okay, so it's right there from B to C. All right, you see that? Now you just shift it over here, and you're going to get length 1. All you have to do is move that compass right there, adjust it, and construct an arc right there, and you found the length of 1. Okay, so let me highlight that point right here. Okay, and we're going to call that point, I don't know, let's call it Z just for fun. Okay, grab your straight edge out. Okay, now connect B and Z together and just draw a line, and it should be parallel to the given line if we did it correctly. Accurately. Okay, so here we go. I'm going to draw that. Whoa, oh, I don't want it that thick. You want your lines thin. Okay, here we go. So you can see that the given line, the starting line, and that line are parallel. You can even put the parallel symbols right there. Those are parallel. And we're almost done with the construction. So what we need to do is draw the new triangle. Okay. Now let me just emphasize something. So from 0 to here is root 2. Okay, this distance right here is 1. Okay, so all I have to do is draw my triangle from A to Z. Again, pause the video if you want to right here. So the new triangle is from A to Z. So on this one here, let me label this root 3 right here. This is root 3. But let me highlight the triangle that I'm talking about, just so that you can see things a little bit better. Okay, I'm talking about this triangle. Well, that's a little bit dark. That's okay. Okay, so there's that new triangle there. The base is root 2, the height is 1, and the hypotenuse is root 3. Okay, that's this triangle that I was talking about earlier. Okay, and that's my goal. Okay, and I'm almost done with the construction. I'm one step away. So hang in there with me here. I know this is a lot. All right, so here we go. We're going to take our compass right here. And we're going to do it the same way the Greeks did, 4,000 years ago. Okay, believe it or not, they knew this stuff. It is amazing. The Greeks were one of the smartest civilizations on the planet and of all time. I mean, if you look at all their art and architecture and mathematics, it's just mind-boggling. Okay, so adjust your compass from A to Z. Remember, let's make a little note here that A to Z is equal to root 3. So if I swing an arc down here, let me change colors to, I don't know, what would be good? Let's go blue again. Okay, so here we go. We're going to construct an arc, and I just found root 3. So where the blue arc intersects the number line, which happens to be right here, is the square root of 3. And that makes sense. The square root of 3, did I do this on the calculator? I don't know. Let's see. The square root of 3 is about 1.7. Okay, so approximately equal to 1.7, which is obviously less than 2. All right. Oh, you know what? I better not put that there. Whoops. This is the square root of 3 here, and the square root of 3 is approximately equal to 1.7, which is less than 2. All right, and it makes sense that it's less than 2 because 1.7 is less than 2. So root 3 better be, to the left of 2. All right. Yes, it's complicated, but after you practice about 10 times, you'll be good. Promise, 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 promise. Okay. All right, moving on. Now the next two ones, believe it or not, are not too bad actually. All right, so let's finish here, and let's move on to the next two constructions. Okay, you're gonna love the next one because it's a piece of cake. All right, so let's get the straight edge over here. Okay, and let's construct root 4. Now root 4, okay, the square root of 4 is just 2. So this is the easiest construction on the planet. So being a little facetious there. All right, so adjust your compass, all right, from 0 to 1. You already know how to do this. I don't have to demonstrate this because I've already demonstrated it twice already tonight. All right, so you adjust your compass from 0 to 1. All right, rotate, all right, and you found 2. All right, so you got to label though. Some of you guys are not labeling your construction, so you got to label. There's 2. All right, there's 1 and there's 0. So, that one was really, really tough. Okay, it took one step. Now, root 5 is a little bit more challenging. Okay, not as challenging as root 3, believe it or not. Okay, I think root 5 is easier, in my opinion. Okay, so the square root of 5. Now, the square root of 5, I'm going to write down here below just so that we can have a little bit of room. Okay, this is our goal. We want to construct root 5. I'm going to draw a triangle here, and we've talked about this in the previous lesson right here, but if we have a hypotenuse of root 5, then the following side lengths that are possible are 2 and 1. Okay? The reason why is because 2 squared plus 1 squared is going to be equal to the square root of 5 squared. Why? Well, 4 plus 1 is equal to 5. That's why. I just used the Pythagorean theorem right now. So what we need to do is get a base of the right triangle of 2 with a height of 1. So we're going to use the previous construction for that. We know how to construct 2. All right, so that just requires the compass. Okay, that was an easy one. Constructing 2 is a piece of cake. All right, so all you do is adjust from 0 to 1. So wherever that is on the number line, right? So you just adjust. And here we go. So go ahead and construct an arc, find out where 2 is, and label it. So there's 2, and I labeled 0 and 1. Now what I need to do is construct a perpendicular through 2, which means I need a point to the right of it. So really I need to construct 3. Okay, so I need to continue this here. So there's 0. The distance from 1 to 2 is obviously length 1. So I need to go over here and I need to construct where 3 is. So I'm going to do that. So I'm just going to swing an arc over here. I'm not going to draw it because I don't want to clutter up the drawing right now. I'm just going to draw where 3 should be. Now again, you could rotate all the way around if you want, and you could draw that entire arc. All right, but it's not necessary. It clutters up the drawing. So I suggest you just figure out where 3 is and mark it. Use your compass. 0 to 1 is 1 unit, 1 to 2 is 1 unit, 2 to 3 is 1 unit. Easy. Now all we do is construct the perpendicular bisector through 2. And guess what? You know how to do that because we did that earlier. Okay, so put your compass at 2. No, excuse me, switch that. We're going to use 1 and 3 now, sorry. We're going to use points 1 and 3. And we're going to construct the perpendicular bisector using points 1 and 3. And it should go right through 2 because 2 is in the middle of 1 and 3. So here we go. So adjust the compass a little bit more than halfway. Switch hands. Move it over to 3 and repeat it. Now those two green arcs intersect. You guys should be getting good at the perpendicular bisector already. So they intersect up top. They intersect down below. Get your handy dandy straight edge and let's bust out the perpendicular bisector. Here we go. Alright, so line up those intersection points and it should line up and go right through 2. Okay, if we do it correctly and accurately. Okay, so here we go. Whoops, that's too dark. Let's make them thin. Ah! You gotta do it right. Here we go. Let's see if I got this right here. Ooh, I shifted a little bit. There we go. Got to be accurate. Okay, no messing around. Okay, so I've got the length of 2 set up. I need a perpendicular. I just got a perpendicular right here. There's a 90-degree angle. And now I need a vertical height of 1. Well, that's easy to get. Okay, so get your handy dandy straight edge, or excuse me, compass right here. Adjust it from 0 to 1. Here we go. So adjust it from 1 to 2, let's say. You can go from 0 to 1 or 1 to 2, right? It doesn't matter, because if you don't know the distance between 1 and 2 is 1, we're in trouble. All right, go to intervention. We'll talk about that later. Okay, so now we're going to rotate up from 1 up here. Oh, that's too dark. I always tell my students to draw the arcs very thin and light, okay? So be accurate. Okay, so here we go. So now I'm going to use this intersection point right here in red. So what I need to do, I'm going to call this point A. Up here, this point, we're going to call that one B. And then down here at 2, I'm going to call that, oops, not B, I just used that, C. Okay, so we're going to connect points A, B, and C. So, well, A to C is already drawn, C to B is already drawn, so connect A to B. That's what I meant to say. Okay, so here we go. Get your handy dandy straight edge here, and let's construct an arc from 0 to B, excuse me, from A to B. All right, take your straight edge, take your ruler here. Here we go. Uh-oh, I just touched it. Gotta be careful. We can't mess around with the compass or the ruler here. You can't be off on this step because accuracy is important. Let's see if I got it. Oh, I didn't mean to do it in red. Let me try to do it again. Okay. Well, okay, that was dark, but who cares? All right, so let's highlight the one I'm talking about here. I'm talking about this triangle here, ABC. Okay, now let's label the side lengths. Whoops. All right, so this length, this distance from 0 to 2 is obviously length 2. This vertical distance from B to C is 1 unit. And as I said down here below, the hypotenuse is the square root of 5. So the only thing you need to do is adjust your compass from A to B. Okay, so A to B is the square root of 5. So take your compass, all right, and we're going to do this the way the Greeks did it again. We're going to adjust it from A to B and then rotate down, okay? So again, from A to B. Everybody say A to B. All right. Now, let's see here. All right, here we go. So from A to B, it's pretty accurate. Okay, rotate down. There we go. Okay, and that's pretty close. Now, so let's label this, okay? So right here is the square root of 5. All right. And remember, the square root of 5, did I do that already? No, I didn't. The square root of 5 is about 2.2. Okay, so let's note that. So this is about 2.2, which is obviously less than 2.5, so it's less than 2.5 units, which is less than 3. Okay, so it makes sense that it's less than 3, and it's less than half the distance between 2 and 3. So my construction makes sense. It looks good. It looks accurate. Okay, at least to me. All right, and there you have it, my friends. Okay, there are all of the constructions here. And again, this is a video, right? Okay, and since it's a video, guess what? You can pause, play, and rewind and listen to it however you want to, however many times you want to. So, all right, that's the best that I can do on a computer, my friends. I can do better in, with my hands on a piece of paper here, but that's the best that I can do. All right, so this is Mr. Ainsworth here. That's how you construct root 2, root 3, root 4, and root 5. And if you do this and you master all of these and you practice, okay, like I said before, you got to practice. All right, you'll be ready for the next activity. All right, I'll see you then. This is Mr. Ainsworth. I'm out of here. Bye-bye. Okay, as long as I can figure out how to turn the video off, that'd be good. This is too funny. This is the first time I've done this here. All right. Okay.